Hello everybody, hopefully you guys are having a good day. My name is Eddie and welcome back to the channel. I'm going to be doing another stand-up video where I go over a feature or something I've been working on and explain my thought process while I was doing it. Hopefully you guys are liking these videos, so do give it a thumbs up if you do. Leave a comment down below with any of your questions or comments and subscribe to the channel so you don't miss out on any future content. So, let's just hop into it right now. Cool. So this is the new version of our node component that we were working on a couple videos back. A couple of the changes, I don't remember if I had these colors in here. The metrics have changed a bunch. I think I just had the very base metrics before. Actually, in my previous video, I don't think I was even going to the metrics API. I was just grabbing stuff from the resource limits, and that's how I was calculating how much CPU we were using and how our nodes were performing. But now we go to the actual metrics API to get all of our data. And because of that, we now also have the metrics brought down, right? So here we're showing it in megabytes and here we have it in gigabytes. I feel like maybe this could be both in gigabytes, but for now I'm happy with, you know, however scaled down we want to actually have it. And we also now have a list of all the pods and workloads that are running on our actual node, their CPU usage and their memory usage. So for the next few videos, I'm kind of be going over how I got from what we had before and how we got here. Cool. So I'm trying to think, where should I start? I think to start, we can look at what data we're actually getting from the API. So like you guys probably know what our service is actually running. It's a microservice architecture, meaning that we have a bunch of different small servers or small containers all running our workload. So this is our front end, it's just a dumb client that takes in data and renders it out for us. But what's actually going out to Kubernetes in our cluster is a Python API, a fast API is what it's called. And that's actually going and making the request to our Kubernetes cluster, grabbing the data, transforming that data into something that is manageable, and then giving it to our dumb client to render out to the user. It's not really a dumb client, it's very smart. I love it very much, so little pat on the head for our nice little smart client. I feel bad calling it dumb. So we could take a look at the data that we're getting from it. So you could see that every 15 seconds we go out to the server and we make a request and we get some data back. And on the server, see right there, we just made a request. What we get back is this data object, and inside of that data object, we have a list of nodes on that cluster. And on it, we get some information like the amount of CPU that we have available and amount of CPU we've utilized, how much memory we have available, and how much memory we've utilized. We also have a list of pods on there, and we can take a look, and the same kind of information. We have what the CPU limit is and what the actual CPU usage is, along with that namespace and the name that we're seeing all on our UI here. Now, before I was handling all of this through just making dictionaries and putting data inside of them and shipping that off, and that was starting to build up a lot of stress on our system. Not like CPU stress, I guess when you kind of think about this kind of stuff, it's like some mental load on me to kind of remember how all of these things work and how I have to document them and how when I'm passing these things around, what it is my developer experiences. So when I'm talking about stress, that's kind of where I'm talking about. When I'm developing it, it's hard to develop and extend it because of the functionality that I get in my developer experience. And that is what I'm talking about when I'm talking about stress, not actual CPU load and all of that stuff. Dictionaries are very fast, relatively, but stress on just the mental gymnastics that I have to do to iterate on newer and newer versions, right? We don't have type hints. Like when I go now into here and I have a kube node here, I can very quickly now with what I'm about to show you, go kube node and oh look, I have the memory and let's just look at all the underscore, the memory and the CPU and the name, CPU allocated, all the stuff that I actually need is all kind of listed here. And you could actually even see that it tells me what it is that that thing is. It's an integer, it's a float. It could be either of those two things, right? So while I'm developing, I could see what it is that I'm actually working with, what it accepts in. If I were to go in here and go like, hey, kube node dot CPU equals the string hello world. Oh, sorry, I misspelled this. Kube node it's gonna tell me, hey, no, don't do that. That's a bad idea, right? And that is the kind of mental load that I'm talking about, right? When I'm developing this stuff out, I want to very quickly know what it is that I'm getting in and getting out. And I also want ways to be able to transform my data in a sane way, right? My dictionaries, I can't put functions into them, right? Like, I probably could put functions into them and then call them through Lambda and stuff like that, but, right, you don't want to think about that while you're developing. You want sane ways to make data structures and pass them around and know what it is you're putting into them and what it is you're going to be getting out of them. So now that I've done my type safe rant cult talk, we can kind of go into how I achieved that. And the way we did it is through Dataclasses in Python. Dataclasses is a nice library for wrapping classes around this. Now I forget the name of them. Oh my god, decorators. Decorators, that's what they're called. You wrap your classes around decorators and you get a bunch of functionality for it, like being able to define what it is that these things are going to be taking in, taking out, create setters and validators and do all that sorts of fun stuff that make creating these big data structures a breeze. So we have this, we'll take a look at a few of the things inside of here. I'm not going to go super into depth into it. This isn't a tutorial on data class. There's plenty of those out there if you guys want to see it, but this is more of a practical, how is these things used in the real world. So I've created this kube node and it has all of these attributes, right? Name, CPU, memory, all the stuff that we saw here in our console log, right? This is in JavaScript land, but we have all that same Python stuff, right? So the uniformity that you're getting from stuff is the really nice thing about this stuff. I can just pass you I can just pass you this kube node thing, and on my JavaScript side, I have all this stuff just ready to be used. It's great. So we have something like a name, and it takes in a string, right? We can set the default, and we tell it to initialize not to do that for us. And that's really because right now the way that I'm using it is I create an empty Kubernetes node, the representation of what I think a Kubernetes node would be, and then I start, bit by bit putting those things into it as I'm building this object out, and then once it's all built out, I send that off to our little smart client, right? And then we also have other stuff here that's more complex, like this kube pod, which is just a list of these data classes, right? So we start taking these data classes and start building up and being like, oh, well, inside of our kube node, there's going to be a list of Kubernetes pods. And when we say like, oh, kube node, kube pod 0, right? The 0th index of that list. What is the memory of that thing? We have all that typed out, and we could see it and see what it is we're getting in and what it is we're getting out, right? So we have this post in it. So after we initialize, we also want to do some post processing stuff. And really all we're doing is we're just setting a bunch of temporary placeholders for the name and CPU and all that stuff. And moving forward, I'm not going to go over this one just yet. This one's a little bit more complex because it's a factory object, but we'll talk about the name, right? So we have a property, and the first thing, this is just a getter. So whenever we say, give me the name, it's going to run this. And then we also have a setter, and this is whenever we say like name equals hello world, we're going to run this setter function. And the way we do that is, we just can type it all out, and this is how we get those nice little type hints in our LSP, our code editor. But we can go into a more complex one like the CPU. For the CPU property, right, it can be a float. This one can also be an int too, I should say. I'm probably going to write a bug in here, just not even thinking about it, but let's do it. It could be an int or a float, and of course the value here can be int or float, right? And that's what that little line thing means. If you guys didn't know, we're saying, hey, I don't know if the user's going to pass in a floating point, 10.98243, or they're going to give me an integer, a 1, a 10, and 134, right? And then we just return it back to us, right? It just goes and gets self.cpu, which is this one right here, and gives it back to us as a integer or float. Or we could set it, and when we look at the setter, we do some stuff before, right? We just make sure that the value is greater than 0, right? We don't want negative values for CPU resources. Wouldn't make sense, and then we will raise a value error if we try to set it to something that doesn't make sense. So now we have validation, something that if I'm just dumping data into a dictionary, there's no validation there. The validation happens before I put the data in there, not as I'm putting the data in there. So that's another step, right? And every time that I'm doing that, it's this mental load thing where I'm thinking about, oh, how is the data going in and how is the data going out? I'm doing that before, and then it's just complicated, right? Now it's part of the actual thing, right? The essence of a Kubernetes node has all the functionality built into it. It's not, I am, making assumptions about what a Kubernetes node is, and then I'm creating this like abstract concept of one in a dictionary. Hopefully all this rambling is making sense. It's kind of confusing to myself anyway as I'm talking about it, so it really helps to kind of just actually work with this stuff, and once you start doing it, you start realizing just by feeling like, oh, this is so much more simple than the way that I would do things before, if you haven't done data class stuff before. And like I said, the list of pods is the same thing here, right? It's just a list of pods, and we could see that here, right? Like, we have that list of pods, and inside of it is just an array of pods with all the stuff that we get there. So yeah, I've been going on long enough about this stuff. Hopefully you guys see the benefit of switching over to this. I really enjoy it. It's made things a lot easier for me. And in the next video, I'm going to be going over how it is that I actually build these things out, right? As you can see here from our entry point, we're building out one, but we don't actually set any data. In a regular data class thing, I would start going in here and being like name equals hello. Well, I think I would go underscore name. Oh no. No, name equals hello. Something like that, and then that would set the data as I'm doing it. But because there's no initialization, those things don't happen here. We do those things later on iteratively. So that's what I'm going to go over in our next video. Hopefully you guys enjoyed it. Hopefully I didn't ramble on too much. If you guys liked it, give it a like. Comment down below with any of your questions. I imagine that this is a kind of more confusing video than I usually make, so I'll make sure to read all of those and get back to you with any of your questions, right? I'll try and help you guys out. And subscribe to the channel so you guys don't miss out on any of our future content. Have a good one. Bye-bye.